lesson 1 on algebraic expressions. So, if we look at the top of page 350, we are looking at, and there are several different algebraic expressions listed. Now, those expressions, we call those terms. Okay, and I need to erase what we did in the last class. Sorry about that. All right.
Oh, no.
We are looking at algebraic expressions. And algebraic expressions are made up of terms. And those terms might look several different ways like they are at the top of page 350. So let's talk about what some of those mean. Okay? If we had 6D, 6D says that I have D plus D plus D plus D plus D plus D. Okay, that's what that means. That means that the variable D is added 6 times. Okay? I can combine all of my D's and simplify it into 6D, because this is a lot easier. I would much rather write this than this, correct? Mm-hmm. Yeah, absolutely. Okay? And that 6D is called a term. It has our variable, the letter D, and the coefficient, or a number, of 6. Now, if we have two variables next to each other, that means that we multiply them together. All right? But let's say that we had a cubed. If we have the variable a to the 3rd power, what that means is that I have a times a. So it's very, very, very important that we write things correctly, because if I use my exponent, or that little number of 3, it means that my variable is multiplied by itself. If it has a coefficient, it means that they are added. And those are very different. Okay? Any questions about that difference and that discrepancy? No? Fantastic. Very good. I'm going to old school zoom in a little bit. There we go. Okay. Now, if we have an expression, you can't solve an expression because there's nothing to figure out. Okay? We can simplify, we can evaluate, but we cannot solve, because within an expression, there's no equal sign. So everything that we do with an expression, we're going to be rewriting the same quantity in a different way. Let me say that again. In an expression, we're going to rewrite the same quantity in a different way. We're not going to have equal signs, and we cannot solve. We're going to simplify. All right? That also means that unless we're told that x equals something or w equals something, our final answer is probably going to have a variable in it. And a variable is a lowercase cursive letter that represents some quantity. All right? Any questions about that so far? No, we're good? We're all bogey? Okay. So let's look at example 1. What does example 1 say? Raise a hand, please, and read that out for me. Go ahead.
Evaluate 2 in parentheses n plus 3 if n equals -4.
Okay, if n equals -4. So it tells us what our variable represents. It's not always going to do that, but this time it did. So what we need to do, we're going to fill in a -4 for our variable n. Okay? Do I need this set of parentheses inside the parentheses?
No, ma'am.
No. So what I'm going to do, I'm going to erase those parentheses. All right. Could I keep them? Sure. But I don't need them. Then I'm going to add negative 4 plus 3. What is negative 4 plus 3?
Negative 1.
Negative 1. 2 times negative 1. Because if I have a coefficient or a number outside a set of parentheses, that means to multiply. What is 2 times negative 1?
Negative 2.
Negative 2. Fantastic. Negative 2. So, this quantity, 2 times the quantity n plus 3, when n equals negative 4, is the same as saying negative 2. But we're writing it in different ways. Questions? No? Alright. Did we solve anything?
No.
No. We didn't figure out what our variable was equal to. That was given to us. We simplified. We wrote it in a different way. Okay? Now, when I did this, I have my problem. I have my problem rewritten, and I have 2 lines of work. When we do problems like this, what do I need to see? A problem, the problem rewritten, 2 lines of work. Okay? Everybody understand? Okay. These are not going to be quick, easy, no paper problems. It's going to take up some space. You need to be okay with that. You don't understand that? You don't understand this, or you don't understand the work? You don't understand showing the work? Okay, then let's do another example so that you can see what I'm looking for. That is not an excuse for not doing the work. Nice try, though. I can appreciate the effort, but I am going to deny the request. Alright, let's look at example 3, please. What does example 3 say?
For y with a exponent of 3 plus 2 if
Okay.
y equals 3.
Y equals 3. So, the first line of work is our problem. The second line of work says that I substitute my variable for a number if it is given. So I have 4 times 3 to the 3rd power plus 2. Now, my order of operations says that I need to take 3 to the 3rd power. That means that I have 3 times 3 times 3. So let's break it down. What is 3 times 3?
9.
9. What is 9 times 3?
27.
27. So I have 4 times 27 plus 2. Alright. What is 4 times 27?
4 times 27 is
108.
108. Did you say 3 million?
yeah. 3 million is
Okay, let's think about our common sense answer. 3 million is not going to make sense if we're multiplying 27 times 4. Alright? I think we were just calling out a random number. Let's not do that. Shh. No names are on video. We're going to add 2 to the 108. 108 plus 2 gives us 110. So this one had even more lines of work. And it's okay. Yes. I didn't ask if you were going to like showing the work. I said we had to be okay with it. But, shh. Okay. So I have the question that I was asked. The question question that I was asked. Why did I put a 3 when they had a y? Okay. If you open up your book to page 350, like I asked, you will say that in the problem it tells us that y equals 3. So that means that we can replace the y with the number 3 because they are the same quantity. All right? What?
So you can't use big words and try to explain something to somebody. 'Cause then
I
they won't
absolutely can because that is academic vocabulary and we need to get used to that.
get- If you don't know it.
So, are you looking at the problem? Do you see where it says that y equals 3? Do you see where it says y equals 3 in example 3?
Yes, ma'am.
Okay, so that is why we could replace that variable with the number. If we're not told that, we cannot do it. All right? Does that make sense?
Yes, ma'am.
Okay. There's one more thing that we do in this lesson. Nope. The last thing that we do is we create an expression based on a word problem. So look at the bottom of page 351. At the bottom of page 351, we're given a word problem. We need to create an expression. All right? So, could I have someone please volunteer to read example 5? Go ahead.
Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 each week. Write an expression that represents the total amount of money Marissa has saved after any number of weeks.
Okay, so if we're creating an expression based on how much she saves, does the cost of the DVD player matter?
No.
No, so we don't need that information. Okay? We don't need that part. How much money is she saving each week?
$10.
$10. Okay? My other number is a 25. Correct? Is a 25 going to be important in terms of how much money she currently has?
Yes.
Yeah, because that's how much she has before she starts saving. Alright? Now we need a variable. Somebody choose a variable for us. Yes, sir. J. Alright? So we have $10 a week. We have J as a number of weeks. And we have 25, which is what she started with. Now I need some operations. Okay? So, what are we going to do to the 10 and the J? Yes. So, you think we're going to add $10 per week to the number of weeks? We're going to multiply them. Very good. Okay? We're going to multiply them. What are we going to do with that quantity and the $25 that she already has?
You're going to add them together.
We're going to add those together. Okay? Now, does this tell me what I need to do?
No.
Yeah.
Yes, ma'am.
Do I like this format?
Yes, ma'am.
Can this be simplified?
Yes, ma'am. Yeah.
What can I do to the 10 times J?
You can do J with an exponent of 10.
No. Because that would say that I have J times J times J times J times J, and that's not what I have. 10J. Okay, then what? Plus 25. Can I combine weeks and dollars into the same quantity?
No.
If I'm counting weeks and I'm counting quantity dollars, can I combine them?
Yes.
Really?
I said no.
Can I put weeks into my bank account?
No.
No. So, that means I cannot combine these two things. I can't add 10J to 25. Okay, we call those different terms or unlike terms. That means that those two things cannot be combined into one. Does everybody understand that?
Yes, ma'am.
Okay. Are there any questions?
No, ma'am. No, ma'am.
No?
No, ma'am.
We're good to go?
Yes, ma'am.
Fantastic. Thank you.